gain margin equal to 1 by magnitude of the intersection point with minus 180 degrees. So here, as the intersection point moving towards minus infinity, then the gain margin is going to be decrease. So here the increasing order of gain margin we needed. So that means the last one having the smallest gain margin, the second one is medium, the lowest one will be the what? Highest gain margin you are having. So the increasing order of the gain margin is 3, 2, 1. Here we have to write the transfer function to the given root locus diagram. So the poles locations here g of s, h of s equal to one pole is at origin, so k by s. The another pole is minus 3 plus j3. That means if you write in terms of root s plus 3 minus j root 3. For other pole you will get it s plus 3 plus j root 3. If you simplify this, you will get k by s into s plus 3 whole square plus root 3 whole square. So if you simplify this, you will get k by s into s square plus 6s plus 12. So the answer is B. So here we require to find the transfer function. The transfer function equal to C into Si minus A inverse into B plus D. So here D matrix is 0. So hence I can write the transfer function equal to C into Si minus A inverse is adjoint of Si minus A by det of Si minus A into B. So here first you have to find the Si minus A. To find Si minus A, the simple logic is add the S diagonally and change the sign of coefficients. So this will become a Si minus A. Now you write the transfer function. C equal to C is 1 0 into so adjoint. So s plus 3 here s and here plus 1 here 0 divided by det. The det will become s into s plus 3 into b. The b will become 1 0. So if we solve this equation, you'll get it the s plus 3 divided by s into s plus 3. So this s plus 3 numerator denominator cancel. The answer is 1 by s. In this problem given the pole at minus 4, 0 at minus 2, and they are asking what is the maximum phase lead angle and what frequency occurs. If write a transfer function to the given information, you will get s plus 2 divided by s plus 4. Convert into time constant form. Then you will get it 2 if you take it common, 1 plus 0.5 S divided by 4, if you take it common, 1 plus 0.25 S. You compare with the standard form of the compensator, 1 plus alpha tau S by 1 plus tau S. Then alpha tau equal to 0.5 and tau equal to 0.25. Then get the value of alpha. The alpha you'll get it 2. Then pi m equal to sine inverse of alpha minus 1 by alpha plus 1. So sine inverse of 2 minus 1 by 2 plus 1. If you solve this, you will get a 19.47 degrees. And omega m equal to 1 by tau root alpha. If you substitute tau and alpha value, you will get the answer is root 8 radians per seconds. So here we require to find the K value to get the gain margin equal to 40 dB. And the given polar plot for the K equal to 10. So we should include the K in intersection point. So for that, product the K divided by given K value. So this is the information from the polar plot. The other information given gain margin is 40 dB. So gain margin equal to minus 20 log of magnitude. So now gain margin 40 given. 40 equal to minus 20 log of mag m. I can write it here. If you solve this, m equal to 0.01. That means the intersection point with minus 180 should be minus 0.01. So both the equations make equal. So minus 0.1 into K by 10 equal to minus 0.01, because we find the K value to get the gain margin equal to 40 dB. So to get a 40 dB, the intersection point should be minus 0.01. If you solve this, you will get the K equal to 1. So in this problem, we should find the gain margin and phase margin, either positive or negative. So here, the frequency at which the magnitude is 0 dB is called gain crossover frequency. The frequency at phase angle minus 180 is called phase crossover frequency. If you take a projection one on another, the omega PC is greater than omega GC. That means the given system must be stable. The stable system should have the positive gain margin as well as the positive phase margin. That means the answer A is correct. So here we require to identify the polar plot. So as we know, the starting angle is minus 90 and the ending angle will be minus 270. So that means the plot should be in this way. Then we require to find here the x value at omega equal to 0. So x equal to minus k tau 1 plus tau 2. So here what is the k value? If you convert into time constant form, then it will be 0.5 divided by s into 1 plus s into 1 plus 0.5 s. Then if we find the x value minus k, so minus 0.5, tau 1 1, tau 2 0.5. If we solve this, minus 1 by 2 into 3 by 2. So the answer is minus 3 by 4. So that means the answer is A. In this problem, we require to find the k value at s equal to plus or minus j1. So here the given angle is 45 degrees. This length is 1 unit. So here also it should be 1 unit. The diagonal distance will be root 2. The k is nothing but product of lengths from point to pole location divided by product of lengths from point to zeros. Here there is no zeros. So simply k equal to product of length from the given point to poles, that is root 2 into root 2 into root 2 root 2, because there are the 4 poles. Thus the answer equal to 4.